So, the next speaker, Thomas Kuhlbusch from Utah, by profession a chemist. And his talk is about measurement of possible CNT emissions during shredding of experimental CNT composites. That fits quite nicely to Cindy's recommendation to look at the end of life. Thomas, the floor is yours.
Thank you. Thanks for the nice introduction. And I also have to say that this presentation fits quite nicely. Andreas Schäfer gave a good introduction this morning on the fate, transport, and what actually is a potential hazard in the environment of carbon nanotubes. And Gerhard Kasper quite nicely said, okay, if there's no exposure, there is no real hazard or risk given to it. So this type of presentation it fits quite nicely into what was presented by the plenary speakers this morning. So the motivation is pretty obvious of this I think first of all I would like to come back and say that most of the work was not actually done by myself, but by the co-workers Burkhard Stahlmecke and Yuri Romasanov and Daniel von Barani. So the background is pretty obvious. We have the motivation that nanomaterials in composites are more and more used, so which means that nanomaterials embedded in a plastic matrix are more and more used, and there are possible release scenarios on how these nanomaterials, plastic materials may degrade and may possibly release some of the nanoparticles embedded in the composite material. And shredding, and as Cindy was giving in the presentation, saying in the presentation before, end of life cycle is a question. Shredding is a process where you do add some mechanical force to these composite materials. So we had to look into this as an example to study whether we can see a release of carbon nanotubes from the shredding process. Carbon nanotubes are more and more used in different products, and along with the InnoCNT activity, it is nowadays also used in helmets for motorcycles, but also in the frames of bicycles and in some other composite materials in cars, as presented this morning already. So what is actually taking place with the carbon nanotubes in these composite materials at the end of the life cycle? And what I would like to present is giving in the beginning a short introduction on the measurement setup, then results from the online measurement, like what Gerhard Kasper was saying, it's nice to have the data online, but as also said by him as well, it's not easy to identify carbon nanotubes or you have a lot of money and possibilities. We also had to have a look into the SEM pictures to identify and see what the actual structure of the material is and to see whether these are carbon nanotubes or not. It was also mentioned this morning, background particles are a major issue. So the logic thing for us was to put it into a glove box. We put the shredder into a glove box as shown here, which is enclosed from all sides quite nicely. And then you see it here in operation by Daniel actually feeding the shredder. And the shredder itself is a process where you have a disc with sharp edges at the side and a mesh around it. So there are different types of shredding systems. This is the shredding type we used here, which is a small, very small shredder compared to the large facilities for industrial shredding. But that's what we can do within a glove box. It's certainly not easy to enclose the big shredders as being used in industry. The big advantages of enclosures is certainly we have a controllable environment, which means especially we know the background particles. We have no real influence from outside activities. And what we see is we have a small volume. So if there is an emission, we actually have relatively high concentration in this small volume. So even small amounts of emission should be detectable within this small enclosure. The way we actually proceeded is when we enclosed it, we flushed the enclosure with HEPA filtered air. And we said, okay, since it's not absolutely tight, it's impossible with this kind of setup. We always said we can start with a concentration of below 1,000 particles per cubic centimeter as a starting point. The measurement was done, and with an SMPS, scanning mobility particle sizer, sizing the particles from 14 nanometers to about 750 nanometers, added by an aerodynamic particle sizer measuring the particles from the size range around 700 nanometers to about 20 micrometers. The shredding was done with a feed rate of 10 grams per minute, and about 200 grams of the sample materials was available for us for each of the runs, and 2 runs were at least done per material. The total duration, therefore, was quite easily, can be calculated about 20 minutes, so that we can have at maximum something about 4 runs of the SMPS system to get a consistent size distribution. The materials we used were 3 different composite materials: polycarbonate, polyamide, and the polyethylene. And with that one, we had it as it is, without any carbon nanotubes added to the material, or we added about 5% or 7.5 weight percent CNT to this composite material prior to the shredding process, certainly. So this is just a picture how it looks like. At the upper left corner, you see the pure polycarbonate as it was used and as it was fed into the shredding process. And then you see on the right side 5% carbon nanotubes, 7.5% carbon nanotubes, and the polycarbonate pure without any carbon nanotubes as it looks like after the shredding process. There are some smaller fractions of the particles, there are larger fractions of the particles of the shredding process which can be observed. So the basic results we actually obtained is here shown for the SMPS size range. You see on the x-axis a size range from 10 nanometers to about 1,000 nanometers, and the number concentration on the y-axis. And which one is the pointer? Oops, that was some. There's a laser pointer there. How you can use that mouse? Okay. What you see here is, as I said, the size range and the number concentration, and we have the background concentration in blue. Then we have the idling of the shredding machine, giving pretty much the same size distribution, but as soon as the shredding here, it was a polycarbonate without any carbon nanotube was added, you see an additional peak of between about 80 nanometers to 40 nanometers of particles being actually emitted by the shredding process itself. So what we said is more or less the idling, which means the running of the machine without any shredding activity, but still running and turning the disk, we set as a background. And then we looked into the ratios to better show the modes of particles being released by the different processes. Here is the same as shown for the SMPS, here for the APS, which is the size range from 700 nanometers to about 20 micrometers. And similarly here, the background concentration, as soon as idling starts, you see an increase here, and then as soon as the actual shredding process starts, the red, you see with the polycarbonate some release of the material. So coming here, you see the overlap. This was a range measured by the APS system. This is the range which was measured by the SMPS systems, and it is always a reporting of the number concentration in ratio to the idling concentration. And what can be pretty nicely be seen that we have 2 modes, whether we have the polycarbonate with no CNT or with CNTs, both modes are visible. One with a mode below 50 nanometers coming from the process, and one mode being in the size range above 1 micrometer. So this mode here, and it's quite interesting to see that this is coming not from the idling, so it shouldn't be just the engine in the idling mode, but that something is actually released by the shredding process itself in the nanosize range. What we see here, when we go into detail, it's certainly some part of it is coming from the engine itself because it's on hour load, running then in the idling. So, but we didn't see any carbon nanotubes later on here. But both modes are here, in this case, visible. If we come from the polycarbonate to the polyamide, we have a similar picture. And what we see here, sorry, I forgot one thing, going back, previous. What is interesting here, we have the highest emission of the sub-micrometer particle number concentration actually for within the polycarbonate for the material where we have no CNT added to it. So coming to the other one, it's actually here where we have the 7 to the polyamide, we have the highest mode in the sub-micrometer size range for the polyamide where we have the 7.5% added. And we have here a logarithmic scale, please take account for that one. And it's pretty similar between the 5% and no CNT for the sub-micrometer range. And we see also a second mode again here for the micrometer size range particles. Coming to the last material, the polyethylene, it's quite interesting to see that in no case we see any release of micrometer particles here. It certainly has the lowest emission, but we do see significant release of the super micrometer size range particles. So in summary, what we can see from these online size distribution measurements reading is we do see differences, but we see between the different material classes difference, but not so much consistent results in the moment whether we have added CNTs to the material or not. We have always 2 modes detected, below 50 nanometers and above 1 micrometer. And certainly within the differences we see between the materials, we want to check and recheck again with some new production of polyamide and polycarbonate material to see whether we get the same results if we get a different batch of material delivered to us again from the company. And interestingly, polyethylene didn't show any sub-micrometer emission range of particles. When we went into details, we actually couldn't find, even though we were looking for single carbon nanotubes, we couldn't identify any really single carbon nanotubes. What we frequently saw on the materials we were looking at was this type of picture where we can see here that we have different fibers actually coming out of the surface here, which could be detected here in this case for the 7.5% carbon nanotubes added. In summary, for this study at least, particle release by shredding was studied as part of the shredding process, as part of the end-of-life cycle, which may take place with the composite material polycarbonate, polyamide, and polyethylene. One resume, similar to what was said before, it was not easy to detect it online, in situ, in air, any fibers, so we had to go and had a look using SEM pictures. We always detected 2 modes, one in the supermicron and one in the submicrometer size range. And in the bigger particles, we could clearly identify the fibers being enclosed and still attached either on top of it, which we could see sometimes as well, but most of the case really embedded still with one end to it in the material itself. So there was not really an evidence that we could identify at this study a release from the matrix itself of single fibers. And this is consistent at least with the publication what Wendel Wohleben published last year in 2011. So with that, I certainly didn't want to do this, but thank you for your attention and the sponsors for the money. Thank you.
Thank you so much, Thomas. Fascinating set of results. It sort of implies, particularly for polycarbonate and polyamide, that the carbon nanotubes are doing something to the structure of the polymer and making it more shreddable.
Yeah, it seems, yeah.
Yeah, the shred.
It's interesting,
yes.
At least.
Michael?
Well, thank you. Very nice presentation. I was curious, these carbon nanotubes, what length do they have approximately, and do you have any information about the stability of these particles that are released if you would put them into like different tests of biostability, like biodigestive systems, to have any chance to, when we inhale like 4 or 5 micrometer sized particles of these, to have anything that is of potential hazard to humans?
I didn't mention it, sorry, but the material being actually embedded in the composite material was all bitubes material. So it was a material which was partially presented and introduced already by Andreas Schäffer this morning. So the particle length was about 200 nanometers to a micrometer, and the number of multivolt was about 3 to 5 multivolts along that line. Biodegradability, good question. There's quite some debate. No, there wasn't any testing to my knowledge. Andreas, do you know any testing of the bitubes and biodegradability?
current project together with ETH Zurich on this aspect, and they use different microorganisms cultured in media, and these 14C labeled nanotubes are the substrate, so to speak. But so far, I was told there is
no result,
nothing happening to this.
It was about the resulting particles.
Ah, okay, yeah. The resulting particles, no. But maybe the next question, I think, well, there was something about release as well. And there are some other projects along that line ongoing, but results are not public as far as I know in the minute.
Okay, well, I do have to watch time very carefully because we're now beginning to run over, and in all fairness, we must give our last speaker some time to speak, but clearly some very interesting homeopathic effects of carbon nanotubes in polymers we need to explore now.
Good, thank you.
Thank you.